Hello viewers, thank you for tuning in again. I'm so grateful for you coming back again. Today's question is this exponential equation. We want to find the value of x in this exponential equation, and in a moment I'm going to walk you through the process one step at a time. So just sit back and watch this video. If you find value at the end of the day, please consider subscribing. Alright, so let us go on to the question right now. Alright, the first thing I want to do, viewers, I would like to divide both sides by 3 to the power x, and let's see how it's going to turn out to be. So if I divide here by 3 to the power x, all these guys by 3 to the power x. Of course, this guy and this guy will cancel out, so I have 1 here, so plus. Now I want you to remember one of the exponential laws. It says if I have a to the power n upon b to the power n, you can see that in this case, the b's both have the same power. So I'm going to rewrite this guy as a upon b, now all to the power positive n, okay? So it's very true. So that's exactly what I'm going to do right here and this guy. So I have here to be 9 upon 3 all to the power x, then I have it to be 27 upon 3 all to the power x. And of course, 9 can divide 3, so we have 1 plus. If 9 divides 3, we have how much? We have 3 all to the power x equal to 27 divides 3, I'll have, 3 divides 27, 3 divides 27, I'll have 9 all to the power x. And also, I wish to write 9 as 3 to the power 2. Yes, because I actually have a point of doing this. Let me show you why I'm doing that. So I have it to become 1 plus 3 to the power x is equal to 3 to the power 2 all to the power x. And also from exponential laws, remember that if I have a to the power n all to the power n, I can write this guy as a to the power n all to the power n. As if to say this guy is going to come in and this one is going outside. You know, it's multiplication and it is commutative, so it's very possible. So this guy is going to go out and this one is going to come inside. So I have this guy to become. So let me take off these guys from here. So I have this guy to become 1 plus 3 to the power x is equal to 3 to the power x all to the power 2. Okay, that is just what I want. And you can see now that I can easily bring up a substitution. I will say let 3 to the power x be equal to y. And let's see how it's going to become. So we have 1 plus, this guy becomes y, then equal to, this guy becomes y, then remember it has a square, so y squared. Now we have a quadratic equation, and that's why we are doing all of this substitution, because it's going to lead us to a quadratic equation. The next thing we're going to do right here is to solve this. Let me arrange this quadratic equation in standard form. So I'll take these guys and these guys to this side, so I have y squared minus y minus 1 is equal to 0. And you can see that this quadratic equation is not factorizable, so I'm going to solve it using the quadratic formula. Now, the quadratic formula is giving us y1, 2 is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so the next thing you want to do is to find in the value of a, b, and c and plug into this formula. So from here, I'm going to get the value of a, b, and c. Now the value of a is a coefficient of y squared, which is 1. The value of b is a coefficient of y, which is minus 1. And the value of c is a constant term, which is also minus 1. So you can see I have the value of a, b, and c, and I'm going to plug it into this formula to obtain the values of y. So this guy is going to become y1, 2, please manage the board. y1, 2 is equal to minus b is minus 1 plus or minus square root of minus 1 squared minus 4 times 1 times minus 1. Okay, all over 2 times 1. So here becomes positive 1 plus or minus square root of 1 squared is 1 minus 1 squared is 1. Then this guy minus 4 times 1 times minus 1 is going to give me plus 4 all over 2. So at this point, it's going to become 1 plus or minus square root of 5 upon 2. So that is the value of y1, 2. So the next thing you want to do is to split the values of y1 and y2 by checking out this plus and minus sign. So we have y1 is 1 plus root 5 upon 2, and y2 is 1 minus root 5 upon 2. Now we have the values of y1 and y2. So we're going to recall this statement we made earlier so that we can easily obtain the real values of x. So let me take off these guys away from here. In fact, I'll take all of these guys from here, but just remember this guy. Yeah. Okay, viewers. So now we recall that 3 to the power x is equal to y. Okay, so we call this position 2 to the power x is equal to y, and now we have two values of y. So we're going to solve this guy in two ways. So I have this first one, 3 to the power x is equal to the first value of y, which is 1 plus root 5 upon 2, and for this guy, this is 3 to the power x is equal to 1 minus root 5 upon 2. Okay, I know you should know that this is the golden ratio, okay? So that is it. So now look at this guy. Whatever be the value of x, we cannot have a negative result. So this guy is going to be ignored. We're going to ignore this guy and work with this guy because this is a positive result. And of course, we can have a positive result for values of x. So at this point, you want to solve for x. You can take the natural logarithm of both sides from here. So you have the ln of 3 to the power x is equal to the ln of 1 plus root 5 upon 2. And of course, you know this guy is going to fall behind. So you have x ln 3 is equal to ln 1 plus root 5 upon 2. And you divide both sides by ln 3. Divide here by ln 3. This guy is going to cancel out. So therefore, x is equal to natural logarithm of 1 plus root 5 upon 2, all divided by the natural logarithm of 3. So viewers, this is the value of x that can satisfy the given exponential equation. If you find value from this video, I want you to please consider subscribing so I can see you in the next video tutorial. Have a nice day and God bless you. Bye bye.